The line where the ocean meets the land has always been a place of change, but today, that change feels different. It feels faster, more relentless. The global mean sea level, according to the latest satellite data, is measurably higher than it was just a decade ago. For hundreds of millions of people living in low-lying coastal regions, this is not an abstract scientific fact. It is a slow-motion crisis unfolding in their backyards, salting their fields, threatening their homes. It is the quiet creep of a changing ocean, a persistent advance that old maps can no longer accurately describe. We are living in a world where the sea is steadily reclaiming territory we once thought was permanently ours. The problem is not just the rising water. In many of the world's most vulnerable coastal cities and deltas, Jakarta, New Orleans, the land itself is sinking. This phenomenon, known as subsidence, is often caused by the extraction of groundwater, oil, gas, or the natural compaction of river delta sediments. When rising seas combine with sinking land, the effect is brutally amplified. A few millimeters of sea level rise per year can become a few centimeters of relative sea level rise. This is the double threat that communities face. The stakes are immense, involving not just property, infrastructure, entire cultures, economies, ecosystems that have been built over centuries at the water's edge. This reality forces a difficult conversation about how we protect ourselves. For generations, the answer was simple and direct: build a wall. We have lined our coasts with concrete, rock, steel, creating hard barriers designed to hold the ocean back. It is an understandable impulse, a desire for certainty in the face of a powerful and unpredictable force. Faced with the limitations of concrete, a new philosophy of coastal defense is emerging. It is one that seeks to work with nature rather than against it. Instead of building rigid walls to block the sea, this approach uses living infrastructure to calm it. The goal is not to stop the water, but to slow it down, to dissipate its energy, and to encourage the natural processes that build and sustain coastlines. This thinking draws inspiration from the world's most effective coastal engineers, coral reefs and mangrove forests. These natural systems have been protecting shorelines for millennia, adapting and growing as conditions change. The floating shield is a technology born from this philosophy. The floating shield is not a wall. It is a large, flexible, and permeable matrix designed to mimic the wave-damping function of a natural ecosystem, typically anchored a few hundred meters offshore, sitting at the water's surface where wave energy is at its peak. As waves enter the matrix, they are not reflected back. Instead, their energy is disrupted and scattered. The complex geometry forces water through a maze of small pathways, causing friction and turbulence that sap the wave's power. By the time the water passes through the floating shield, its energy has been significantly reduced. The waves that reach the shoreline are smaller, calmer, and less erosive. A protected low-energy zone allows natural processes to recover. Unlike a solid barrier, the shield allows for the natural flow of tides, nutrients, and marine life. It protects without isolating, shifting from static, gray infrastructure to dynamic, green-blue infrastructure, catalyst, not permanent fixture. The effectiveness of the floating shield lies in the intricate design of its individual components. Each hexagonal pod is a marvel of material science and geometric efficiency, engineered to be both strong and life-promoting. The pods are not solid blocks. They are 3D printed with an internal lattice structure known as a triply periodic minimal surface, or TPMS. Inspired by natural forms like sea urchin skeletons, TPMS provides incredible strength with minimal material. A continuous, porous interior that is lightweight and resilient to wave pressure. The material is just as innovative. Instead of conventional concrete or plastic, the shield uses a specially formulated bio-composite. A key ingredient is diatomaceous earth, a silica-rich powder made from fossilized diatoms. Its porosity and vast internal surface area welcome marine life. Crucially, the bio-composite is pH neutral, unlike typical concrete that leaches alkaline chemicals harmful to sensitive species. Concrete carries a heavy carbon footprint, while this composite can be made at lower temperatures and is designed to help the environment, absorbing dissolved inorganic carbon through slow mineralization, acting as a passive carbon sink. The hexagonal shape is no accident. Nature favors hexagons for efficiency. Honeycombs, basalt columns, pods tessellate without gaps, forming a strong, stable yet flexible mat. Interlocking joints let the shield move with the sea, distributing forces across the whole, preventing catastrophic failures that plague rigid sea walls. So, the design really is about working with motion, not fighting it. The floating shield is more than just a wave break. It is an ecological nursery. Its ultimate goal is to facilitate the growth of a self-sustaining, natural coastal defense. At the center of many pods is a protected cradle for a young mangrove. It provides a calm microenvironment where roots establish without being torn away by waves or strong currents. For the first critical years, the pod acts as a guardian, offering stability and protection in the turbulent intertidal zone where mangroves struggle to take root on their own. The underside carries rounded projections that mimic mangrove prop roots. As water moves around them, velocity drops, suspended sediment settles, and the seabed begins to rise beneath and behind the shield. Over months and years, accretion raises the sea floor. Nurtured saplings send roots into nutrient-rich mud, anchoring as land builds up. The pods are intentionally finite. Biodegradable polymers like PHA are slowly consumed by marine microbes over 5 to 10 years. By design. Year 1, sapling in pod. Year 3, roots established, sediment building. Year 7, mangroves forming a forest, pods starting to dissolve. By then, a dense interlocking forest provides superior defense, alive, adaptive, self-repairing. The shield kickstarts the cycle, then gracefully exits when nature can stand on its own. To ensure it is working effectively and to quantify its benefits, the floating shield is embedded with a network of sophisticated sensors. This smart shield acts as a nervous system, streaming high-resolution data. Sensors monitor wave height, wave period, water pressure. Accelerometers track pod motion to show energy dissipation in real time. Engineers verify performance on dashboards. Beyond physics, the network monitors ecological health, salinity, temperature, turbidity, dissolved oxygen, creating a long-term record of marine conditions behind the shield. Automated cameras and hydrophones processed by AI count juvenile fish using the pods as nurseries, identify invertebrates colonizing the bio-composite, and track habitat vibrancy, tangible evidence of recovery. One powerful function is measuring blue carbon sequestration, CO2 stored by coastal ecosystems. On-site sensors capture sediment accretion, satellite imagery tracks change, drone LiDAR maps biomass. Data is recorded on a secure digital ledger. Verified data becomes a financial instrument, generating high-quality blue carbon credits. That revenue helps finance installs and monitoring. The shield becomes a climate-positive asset, attracting blue bonds. All of these sensors turn the structure into both protector and accountant of the sea. The theoretical promise of the floating shield has been put to the test in the Mekong Delta in Vietnam. This vast, low-lying delta is home to millions, a hub for agriculture and aquaculture. It faces rapid land subsidence and sea level rise, causing severe coastal erosion. In late 2024, a 500-meter pilot was deployed along a coast retreating several meters per year. After 18 months of continuous monitoring, results were measurable and encouraging. The primary goal, reducing erosion, was achieved with remarkable success. Sensor data and satellite analysis showed shoreline retreat slowed by approximately 40% compared to adjacent unprotected areas. The shield trapped sediment effectively in the Mekong's turbid waters. Over 18 months, monitoring recorded an average of 12 centimeters of new seabed behind the shield, stabilizing the shore and buying precious time. Mangrove saplings and pod cradles thrived with over 90% survival, far better than unprotected plantings, creating a new green fringe along the coast. Ecological and economic co-benefits appeared quickly. Improved catches of fish and crab as nursery habitat expanded, and the project's first tranche of verified blue carbon credits based on measured sediment accretion and mangrove growth. These early results are a powerful proof of concept, demonstrating that the floating shield can deliver interconnected ecological, social, and economic benefits in a real-world setting. A successful adaptation project must do more than protect property. It must support people. The floating shield is designed to create new economic opportunities and strengthen local livelihoods. Manufacturing and assembly can be done locally, building skilled jobs in digital fabrication and material science, while deployments engage local boat operators in labor. The biggest opportunity is long-term stewardship, shifting jobs from resource extraction to regeneration, training former mangrove loggers and struggling fisherfolk as mangrove guardians and eco-rangers. As ecosystems recover, high-value, low-impact ecotourism grows. Local guides, homestays, bird-watching, kayaking, and learning about the living shoreline. Large projects raise valid concerns. Ocean views, fishing grounds, navigation. Transparent, inclusive planning is essential. Developers must engage leaders, fishing associations, and residents. Designs can use submerged or lower-profile pods where views are valued. There's moral hazard concern that adaptation dulls mitigation. Proponents note the shield is not a substitute for climate action, it's a tool for locked-in impacts. Regulatory sandboxes enable monitored trials. Blue bonds and strong ESG guardrails help ensure just sustainable outcomes. So, yeah, those safeguards are, really important. In the end, the floating shield offers a vision of a different relationship with our changing oceans. It asks us to move away from confrontation, building higher and stronger walls in a futile attempt to hold back an unstoppable force. Instead, it invites us to work with the water, using natural principles to guide the ocean's energy and foster resilience. The shield is not a singular perfect answer. It is a tool, one piece in a much larger puzzle of adaptation. Its success depends not just on engineering, but on how wisely we deploy it. This technology is a bridge between a vulnerable present and a more resilient future. A bridge between human engineering and living ecosystems. It buys precious time, creating a window of calm during which nature's own defenses can re-establish. The true measure of success is not the longevity of the structure, but the maturity of the forest it leaves behind. It can turn an anxious, eroding coastline into a generative asset, protects homes, creates jobs, restores fisheries, sequesters carbon, delivering multiple benefits at once. However, we must remain clear-eyed. Nature-based solutions are essential for the climate change we can no longer avoid, but they are not a cure. The most important work is the urgent reduction of greenhouse gas emissions. Without that, no engineering can keep pace. These adaptations must be paired with ambitious mitigation. The ocean's quiet advance calls for good science, deep community engagement, and a willingness to learn from nature. The floating shield is one such response, living, adaptable, regenerative. It is a hopeful step, a tangible way to help communities stand firm on a changing planet. It is an invitation to meet our time's challenge not with concrete and conflict, but with intelligence, partnership, and a profound respect for the natural world.